All right, we're going to be talking about exponents and prime factorization. So go ahead and get that written at the top of your notebook for your title, Exponents and Prime Factorization. And then you're going to take this piece of construction paper. This is actually just cut from a vertical piece of construction paper, and this is a third of a piece of construction paper. If you're in my class, you already have that ready and cut for you. So you are going to fold this in half, as you can see in front of you. Just folded it long ways in half. And then I'm going to fold that again. So if I fold half in half, I'm actually creating fourths. So now I've created fourths, and I'm going to open that back up. And this is what we're going to be using to be creating our exponent foldable today. I want you to go ahead and start by grabbing a marker, a pen, or a pencil, whatever you like to use. This is your foldable, so you do with it what you want. And I want you to, on the first crease, I want you to put a big equal sign in the middle. And on the last crease, I want you to put a big equal sign in the middle, just as you can see here. So that's the end of my line there, and there's that. All right, eventually we're going to be folding this in, so actually you might kind of want to make those look like they go together. I don't know. I'll make it a little prettier. I'm all about a pretty notebook, so I got to extend this now, you guys. All right, here we go. So now we have our pretty equal signs. And we are going to be using this to express what exponents mean or represent. So on the left side, all the way to the left, we are going to write an exponent situation. We are going to write 2 to the 4th power. 2 to the 4th power. Now I'm going to change colors here. You are welcome to change colors or not. And I'm going to do that so that I can represent, so I can explain what both of these mean. We talked about this yesterday if you were in my class. So the 2 is called the base. And the 4 is called the exponent. Please feel free to pause the video anytime you need to catch up. So now we are looking at an exponent of 4 with a base of 2. So this tells us what we need to do with our exponent. Between your two equal signs, I want you to represent the expanded form of 2 to the 4th power. So what this looks like is your base, the exponent amount of times. So I need to write 4 2's. My base is the number that I should be seeing in expanded form. So I need 2 times 2 times 2 times 2. Notice I'm trying to use my space wisely. Make sure that you're doing the same. You don't want 4 tiny 2's. I mean, unless that's what you want to do. It is your notebook. This is the expanded form. So I know that I had my base number 4 times because that's what my exponent told me to do. And exponential situations are always marked with multiplication. A lot of people would make the misconception to think that this is 8 and they would just do 2 times 4. The problem with that is if I wanted 2 times 4, I would literally just write 2 times 4 because there's no need for it. The purpose of exponents is to simplify math. This is 2 times 2 times 2 times 2. I don't need to know 2 times 2 times 2 times 2 or I don't need to write all of this out if I can write it in this simplified form of 2 to the 4th power. So let's solve this. You want to make sure that you're not going 2, 4, 6, 8. Uh-oh, we ended up with 8 again. We aren't adding. That's actually adding if you just count by 2's. We need to make sure that we're multiplying. So 2 times 2 is 4. 2 times 2 is 4, and 4 times 4 is 16. So this exponent situation actually gives me an answer of 16, which should go out here on the side. So now we have our situation of 2 to the 4th power, sorry, it barely fits, but 2 to the 4th power, in expanded form is 2 times 2 times 2 times 2, which equals 16. So now what I want you to do is we're going to close this. And when I mean close it, you want to keep the 2 to the 4th power down, and you are going to bring the 16 over to the 2 to the 4th power. So 2 to the 4th power is 16. And if you want to know how, you can see that when you expand your foldable. All right? You need to glue the back of this and get it put into your notebook like this. I want you to add one more thing for me, please. And that's going to be the word form of this. We're going to add a few little things to the bottom of this once you get it glued in. The first thing you're going to say is word form. I didn't actually glue mine, so it's moving for me. Okay. Word form is 2 to the 4th power. 2 to the 4th power. And we're going to do 2 more examples because there's 2 kind of funky ones. All of these are to the 4th power. If it was 5...
Family, just a reminder,
excuse us, sorry.
An ethics review is taking place either this morning before school, starting at 8:10 in A107, or after school at 4:15. Jill McKee, if you'll stop by A107 on your way to duty, wanted to come tell you what's going on up there. Thank you.
Okay, sorry for the interruption. Next, I want you to grab a pen or a marker, whatever you want, maybe a pencil. That's what most people use in math, but I like to be a little colorful. We're going to do 2 other examples. So let's just do 4 to the 2nd power. Notice I read it just the same way as this. 4 to the 2nd power. 4 to the 2nd power. 4 is my base, 2 is my exponent. It can be written 4 to the 2nd power. But when it has a 2 as an exponent, it is more likely to be called 4 squared. So squared is what I want you to understand. If I say squared or you hear squared, that means it has an exponent of 2. Let's talk about another situation that might be called something different. And that's when you have, let's say, 5 to the 3rd power. You can read that 5 to the 3rd power. These are powers. But most of the time, you will hear it called 5 cubed. So I want you to understand, if you hear cubed, that means that it is an exponent to the 3rd power. Let's do 2 examples really quick, just so we have something good in our notebooks, and we will move on. So let's say we have 6 squared. When I say what does that mean, I'm not actually looking for an answer, I'm looking for the expanded form. So 6 squared actually represents 6 times 6. And I want you to say that to yourself, 6 times 6, because many people will look at this and immediately think in their head 12, because that's how we've been trained. But we don't want to think 12, because when you say 6 times 6, are you really going to think 12? I don't think so. You may, but who knows? 6 times 6 gives us 36. So that is going to be our answer there. And we'll do one more. Let's go ahead and do 8 cubed, or 8 to the 3rd power. What does that mean? In expanded form, that would mean 8 times 8 times 8. Not 24. 8 times 8 is 64, just by itself. So we want to make sure that we aren't sitting here and thinking that it's 8 times 3. It's very important. So, and you might even want to write 8 times 8 is 64. Now, who knows mentally what 64 times 8 is? Not most people. So it's fine to go to the side and say 64 times 8. And yes, when we write multiplication like this, we usually do use the x, and that's fine. 8 times 4 is 32. 6 times 8 is 48, plus 3, 51. So our answer here is actually 512, which is way different than 24. Okay, we're going to slide over to the next page, and I want you to go ahead and put prime factorization at the top of this as well, because I want you to continuously think. This is prime factorization on this side of the page. And I have also represented our first 5 prime numbers, 2, 3, 5, 7, 11. So make sure that you have that in your notes. I pulled that straight from my sieve of Eratosthenes that we just discovered earlier. So I know that my first prime numbers are 2, 3, 5, 7, and 11. So go ahead and get those written down because they're extremely helpful when working with prime factorization. Remember, at any time you can pause the video if you need more time to work in your notebook. Next, I want you to take the short piece of paper that I gave you. This is actually just half of the piece of paper that we were using for the exponent foldable. So it's a third of a construction piece of paper vertically, and then that is cut in half. Go ahead and take this piece of paper, and I'm gonna fold it up. We're actually gonna do fourths, just like we did on the last one, and I'm gonna fold it up again to create fourths. So it should end up looking about like this when you're done with it, and then go ahead and open that up. I'm going to open it up all the way, but in the first section, which you should have 4 of, I want you to write the number 36. We are going to find the prime factorization for 36, and so the first thing I want you to do is branch off, and we're going to make a factor tree into our next section. So we need to find 2 factors that make 36. There's tons of factors that make 36. We could do 3 and 12, we could do 2 and 18, but I really like 6 times 6. And I usually just write it like this, but some students like to put that multiplication sign in the middle so they can see that 6 times 6 is 36, and it makes more sense to them. That's completely fine if that's what you'd like to do. Now, our goal is to make a prime factorization. We have found the factors of 36, but it's not prime factors, so we need to keep going. So I'm going to branch off 6, and I'm going to keep going until I find some of these prime numbers, or maybe even other prime numbers. So I know that 2 times 3 is 6, and those are on my top 5 prime numbers, and I know that they're prime. So I'm going to go ahead and circle them. And I know that's the end of this side of my factor tree because I've made my little cherries at the end. I like to circle these so you can see them nice and big. I have had students where they circle really small and then they can't really tell what that number is. So let's make sure we don't do that. Then we have another 6, so I'm going to go ahead and do 2 times 3 again and circle those. So I want you to make sure that you're knowing that this is called a factor tree. So let's make sure we write that. And I'm just going to put a little arrow up so that you can see that this is what I'm talking about when I ask for a factor tree. On your test, I will ask you for prime factorizations, but it says, make a factor tree to create a prime factorization. So I will be looking for those factor trees. Next, I want you to see that 2, and I'm going to use a new form of multiplication for you guys, 2 times 2, and I like to put these in order from least to greatest. So notice you can actually use parentheses for multiplication. Times 3 equals 36. So your prime factorization needs to equal the number that you started with. That's the point of it. Every number in the world can be broken down into just prime numbers. So 2 times 2 times 3 times 3 is 36. It is a great way to check yourself as well. So we're in our third section of our little fold. Now what I want you to do is notice that this is going to fold up. We are going to write in our last section. So you can even fold it up if you want to right now, but we do need the information inside. So notice that I am working in this last section, and we are going to write our prime factorization, and then we are also going to write it in exponent form. So I'm going to say my prime factorization big fancy word, is 2 times 2 times 3 times 3. So when you're asked for a prime factorization, that's how you would write it. You don't really need to put the equals 36. I'm just showing you that it should. Notice I used parentheses up here for multiplication, and I'm using dots down here, and that's fine. Now we're going to show that in exponent form. So we just went over exponents. We know that we can have 4 to the 4th power is 2 times 2 times 2 times 2. Well, what if I had 2 2s? How would I represent that? The base needs to be the number that you see, so my base is a 2, and the exponent is how many times you see that number. So I see that number twice. So that can be written 2 to the second power. Times, remember it's always representing multiplication, 3. 3 is my base because it's the number that I see, and my exponent is how many times I see that number. I see that number twice, so that is 2. When we glue this in, we are actually going to fold it up like this, where you're hiding the factor tree, but anytime you're wondering, how did I get these prime factorizations in exponent form? You can open it up, you can see your factor tree, and everything is beautiful. So that is how you are going to glue this into your notebook. Okay, we're gonna do one more. I'm gonna move pretty quickly, but remember you can pause the video at any time so that you can work at your own pace. So I'm gonna grab another sheet. I'm gonna try to close this up, make sure I'm not gluing it just for time's sake, but see, I'm wasting time here with this. Okay, so next I'm gonna do the same thing. I'm gonna fold it into fourths, so I fold it in half first, and then I'm gonna fold it over into fourths, and open it back up. The number that we're gonna do this time is 120. I'm trying to see if that's really the number I want to use, but I think I do. So we will put 120 pretty large at the top. Feel free to change colors anytime you want. You can change when I change. You can use the same color for everything. This is your notebook, how you want it to look. So the first section has my number, and then I'm going to branch down to the second section of my folds, and I'm going to do my factor tree. The reason I chose 120 is because it is a multiple of 10. That means if I look at my divisibility rules, this ends in a 0, meaning that I can use 10 as one of my factors. I love this because if I use 10 for 0, then the other number that's left is actually the factor that goes on the other side. So 12 times 10 is 120. So I'm going to go ahead and write 12 on this side. So if you have a huge number or a big number that ends in a 0, help yourself out and use 10, and then the other number goes on the other side. So now we need to break these down. I don't have my first 5 prime numbers yet, so I'm going to keep going. 12 is, there's many ways to get to 12, but I'm going to choose 4 times 3. 3 is in my first 5 prime numbers, so I'm going to go ahead and circle it. I'm going to keep going with 4, and 4 is 2 times 2, which are my prime numbers I've been looking for. So I am done with the 12. So that means 2 times 2 times 3 creates 12. Let's go to 10. 10 is 2 times 5, and those are my prime numbers. So this is my factor tree. It's important if you want to check your work that you're making sure to understand that 2 times 2 times 2, remember I like to put them in order from least to greatest. I have 3 2s, so 2 times 2 times 2 times 3 times 5 should equal 120. If it does not, you made a mistake somewhere and you need to check yourself. So the last thing we need to do is write our prime factorizations and also in exponent form. So I'm going to write prime factorization and my prime factorization is 2 times 2 times 2 times 3 times 5. And when you write your prime factorization, remember you don't have to put equals 20, but you can if you want to. And then exponent form, remember these are my base numbers. So my base numbers are 2 times 3 times 5. And then you go back and do your exponents. 2 I have 3 of. So this is going to be 2 to the 3rd power. Or I could call that 2 cubed. Then 3, I only have 1 of them. You could put an exponent of 1, but there's really no need because 3 already represents 1 3 and 5 represents 1 5. So at this point we're done. You are going to fold this up where you can just see the prime factorizations, and it should be glued in your notebook, and it should look like this.